Okay, welcome back, Chemistry 30. This is the final part of the 16.5 video. So now we're looking at Gibbs energy here. So the relationship here that looks at enthalpy and entropy is this. Delta G equals delta H minus T times delta S. T here for temperature, you notice it's a capital T, which represents Kelvin temperature. So we don't deal with degrees C temperature. What we do is we use Kelvin temperature to ensure that our T value is always positive. If you look at the relationship here to figure out the Kelvin temperature, it's whatever the degree C temperature is plus 273. And that implies that T will always be positive because the lowest temperature you can theoretically get is negative 273 degrees Celsius. If we take that and add 273, we get 0 Kelvin. So all numbers for T will be a positive number. Okay, and at negative 273, of course, all molecular motion is believed to stop, etc. Now, so all these stars here represent values for G. Now, if we get G being a positive value, that means the reaction will be non-spontaneous. If G works out to be a negative value, though, it'll be a spontaneous reaction. If you take a look why, there's a little summary chart here. So the favorable conditions we mentioned before here, if this is negative, and if this is positive, a negative T times a positive S will give us a negative answer, combined with another negative answer gives us a negative G. So that's always spontaneous. If we get the opposite occurring, positive delta H and a negative S, a negative times a negative is a positive, combined with another positive, we get a positive G. And that would be a non-spontaneous reaction because neither H or S are favorable. So those are the two that we looked at here. The most favorable condition is this right here, in which we have an exothermic reaction and positive entropy, or vice versa. If we have a positive H and a negative S, that's always non-spontaneous. Kind of in between there, it depends on how big each of those numbers are, as well as the Kelvin temperature. So we can use that. One of 4 options that are going to happen there. Okay, so if we look at the first example on the next page, giving you some values for delta H, T, and S, you notice that this one's in kilojoules, this one's in joules. They have to be in the same unit, so all I did here was convert this into joules. Now if we take a look here, we have a positive H and a positive S. Positive H, positive S, it's going to depend upon what my other values are. So substituting those in, our H is 145,000, our T is 293 Kelvin, our entropy is 195 joules per Kelvin. You'll notice that the Kelvin temperatures cancel and we're left with that. 145,000 minus 57,135, we get 87,865. Since that's a positive number, we will have a non-spontaneous reaction. Okay? Next, and of course I forgot to mention here, kilojoules to joules multiplied by 1,000. Over here, enthalpy is negative, entropy is positive. Oh, there we go. It falls into here, negative enthalpy, positive entropy. It should be a positive number. So if we work through it, negative 232 kilojoules is negative 232,000 joules to match up with this unit. So we have that, negative 232 multiplied by 273 times 138. And you can see here, yes, we get negatives. So it's a spontaneous reaction.